All right, today we are going to open up your book to, let's see, what page here. All right, turn to page M3, 171. M3, 171. This book has some weird page numbers. That's all right. M3, 171. Do you guys know what a log is? What's a log? Are you sure? Yes, a log is an exponent. Just keep that in mind as we go through today. That will make your life way easier. So what I want you to do, let's do number 1 on the warm-ups together. And then I'll let you do 2, 3, 4. Okay. So today we're going to start. Yesterday I said we were learning how to crawl. Today we're going to walk a little bit. It's not going to be too bad. All right. Convert each logarithmic expression to an exponential equation and then solve. All right. I'm going to put this down here. Number 1. Can you see this? No. I can see this. All right. So number 1. You tell me. This is Spanish. What was the English? What's a log? Which one of those things is the log? It says the log base 10 of this is. So the log is x. So which one's the exponent? The x. It says the log is x. So which one's the exponent? The x, because the log is an exponent. Which one's the base? 10. So 10 to the what? 10 to the x. Write that down. 10 to the x equals what? 0.1. Write that down. 10 to the x equals 0.1. Whew. Now we just got to figure out what x is. Yeah. Okay. Well, is 1/10? Would everybody agree with me that 1/10 is just a fancy way of saying 1/10? Is that true? Yeah. Everybody agrees with that? Okay. Well, 10 to the first power is 10. What would x have to be so that I get 1/10? This is a while ago. This is going to take some thinking, but we did these a while ago. What kind of an exponent would that have to be to make it be positive on the bottom? A negative. So this would be to the negative what power? -1. Try it on your calculator. Type in 10 and raise it to the -1 power. Do you get 0.1? You do. And so that means x is -1. Was a little bit of work. I'd like you to take a couple minutes here and see if you could figure out 2, 3, and 4. Rewrite it using exponential notation and then solve for x. Okay, so start out like you did yesterday. Rewrite it using the exponential notation. Kind of look at how we did number 1 and then see if you can solve for x. So on the IXL, you guys said that it was an easy IXL. That IXL, you had to do a lot of converting between logarithmic and exponential form, back and forth. So that's really all you're doing here. Convert that to the exponential form and then solve for x. Because once you get them into exponential form, a lot of times the answer just jumps right out at you. You're like, oh, well, that's obvious. But the whole point is to put it in exponential form first. If you can do that, then you got a chance. Anybody think they know the answer to number 2? 4 is the right answer. That is exactly the right answer. And the way you figure out that it's 4 is how do you rewrite number 2? It's what to the x? 2 to the x equals. So now you just got to figure out 2 to what power is 16. And so you can kind of do it the caveman method if you want to. 2 to the first power. No, that's not enough. 2 to the second power. No. 2 to the third power. No. 2 to the fourth power. Ooh, there it is. 2 to the fourth power is 16. Therefore, x is 4. That's excellent. If you figured that out, then you're gonna do well today, because that's mostly what we're doing. How about number 3? What do you think the answer to number 3 is? Let's try it. 10 to what power? 10, this is the base. What's the exponent? What is a log? A log is an exponent, right? So here's the base, 10. What's the exponent here? It's not the 9, it's the x. 10 to the x equals 10 to the 9th. The 10 to the 9th, do you remember what we called that yesterday? This is the base, this is the log. What's this? Remember? Argument. Good, that's the argument. Awesome. All right, so now you got to turn on your brain. If 10 to the x is equal to 10 to the 9th, then what's x? 9. See, if they have the same base, don't they have to have the same exponent, right? So yeah, x is 9. Excellent, very good. All right, how about the last one? Number 4. Number 4 is going to be 2 to what power? 2, excellent. 2 to the x power, that's equal to a 4th. This is kind of hard. This is a tougher one. This is kind of like number 1 because it uses negative exponents. So think of it this way. Not that 4. Could I write this 4? All right, 2 to the x. Could I write that 4 as 1 over 2 squared, right? Now, if it's 1 over 2 squared, I'm going to rewrite it over here now. This 2 to the x. Is that the same as 2 to the negative 2 power? Or is this the same? Remember when we did, it's been a while. Remember when we did negative exponents way long ago? If it's a negative exponent, you can make it a positive exponent by putting it in the bottom. So you can do the opposite if you go the other way. So if it's in the bottom and it's positive, you can make it on the top, make it negative. Now that it looks like this, what does x have to equal? There you go. -2. Whew. So that's what we're going to be doing today. Actually, we're just going to be solving logarithmic equations by putting them in exponential form. So turn the page. Turn the page. See this table? This would be an excellent test question. I want you to fill in the blanks. Okay, this is exponential form. This is logarithmic form. They even give you the formula, right? Y equals b to the x. X equals the log base b of y. So let's do the first 2 together, and then I'll let you turn you loose on the rest of these. I just want you to fill these out. This is just like yesterday's IXL. I give you this, you tell me what? This is the log base. What's the base? 12. Log base 12 of what? What's the argument? 144 is the exponent, and the exponent is the log, right? The log is the exponent. So that would be to what? 2. Remember, 12 to the second power equals 144. Is 12 to the second power equal to 144? It is. Now let's go backwards. Look at this one. This is, what's the base? 16 raised to the exponent. The exponent is the log. What's the log? 1/2. 16 to the 1/2 power is equal to the argument, which is 4. Not too bad. All right, now I want you to keep going. All right, write down the rest of them. Again, I'll give you a couple minutes. The more you practice of these, the easier they get. So give the rest of them a try. Just fill out the rest of that table. If you can do this, again, the hard things that we're going to do with logs later will be super easy as long as you understand this. If you can do this, then you'll have no trouble with those. So give those a try. Just rewrite each one in whatever form is missing there. And if you're ever not sure, look up here, because this is what kind of tells you what they each look like. That right there and that right there. And don't forget that natural logarithms have a base of what? No. Natural logarithms have a base of what? It's a letter. E. Natural logs are base E. That's right. So natural logs are base E. So when you get to this one right here, it's almost as if there's a little invisible E right there. That's right. The more of these you do, the easier they get. All right, it looks like a lot of you are done already. So let's go through the answers. Here we go. This one. This is, what's the base? What's the base? Nope. What's the base? The base is the thing that you're raising to the exponent. 10. So I'm going to write log. Why am I not going to write a little 10 right there? It's a common, yeah, this is what we call the common logarithm. And common logarithms are already base 10. So you don't have to put the 10 there. If it says log and it doesn't say any base, then you can assume that the base is 10. So you just say the log of, it's just, it's kind of like if I said the answer is 9 and you said, well, that's the same as 9 to the first power. But 9 to the first power is just 9. So you don't really have to have the exponent of 1 there because it's understood to be there. So you kind of don't want to write a 10 there. Yeah. But you're just learning about these now. So if you put a 10 there, it's not wrong now, but later on, you'll be like, oh yeah, it doesn't need to be there. But for right now, don't worry about it. What's the argument? 100,000. And then what's the log? 5. What's the base on this one? E is approximately 20.086. Not writing very well here. All right. All right, the log base what? Base 2/3. That's a weird base, but it is what it is, right? Log base 2/3. What's the argument? 8/27. Maybe we'll put that in parentheses just to make sure we don't get it. It's not wrong if you didn't. Equals the log, which is, because a log is a what? Is an exponent. The one that's the exponent, that's the log. How about this one? 9 to the 3/2 equals 27. And you could even check it on your calculator if you were like, boy, I don't know if that looks right or not. You could always check 9 raised to the 3/2. Oops. 3/2. There we go. 9 raised to the 3/2. Oh, it doesn't like what I did there. Let me get rid of that. 9 raised to the 3/2. There we go. 27. That's right. How about this one? 2 raised to the 8 equals x. This one, the log base 6 of equals x. And that's it. This one, for some reason, they did both of them for you. How do we do on that? You starting to get the hang of it? Yes. That's really what you did yesterday in the IXL. So everybody yesterday thought that's super easy. Look at the next page, because sometimes there's more than one way to learn how to do this. And you might not like the way that I just taught you. You might like this way better, because this way works for some people. I say this, but I don't write it this way, but they wrote it this way. So this is the same thing we did yesterday, but notice they said the base to the exponent equals the argument, right? And that's the same as the log base, whatever the base is, of the argument equals the exponent. If you want to think of it that way, think of it that way. Okay, down here it says, it is important to become familiar with how the base, the argument, and the exponent fit into a logarithmic equation. So there's some vocabulary for you. Logarithmic equation. It's an equation that contains a logarithm. That's all it is. All right, arrange the given terms to create a true logarithmic equation. Let's take those 3 numbers and write something in exponential form. What to the what equals the what? This is kind of like a puzzle. These are the 3 pieces of the puzzle. You tell me how I put them together so that they make a good equation. What to the what power equals what? 7 to the equals 49. There you go. That's it. Now that is not a logarithmic equation, but that is an exponential equation. Could you turn this exponential equation into a logarithmic one? I think you could. So how are we going to do that? So you're going to write the log base what? Of what number? 49 is, there you go. You did it. So take the puzzle pieces and try to make something. Let's take these puzzle pieces and make something. This one's a little tougher though, because there's a negative. So think about think about how we have negative exponents, how they make fractions, right? So what do you think is going to be the base? Just take a wild guess. 6, good. So you got 6 raised to the what power? -3. Is that equal to 1/216? I don't know. Let's try it. Let's just guess and check here. 6 raised to the -3 gives me a decimal. So I'm going to hit math, enter, enter. Oh, how about that? 1/216, just like it says. So we did a little, guessing and checking with the calculator. Now that we know that this is true, could I write a logarithmic equation? Log base 6 of 1/216 is -3. There you go. It's kind of like a puzzle. You're just putting the puzzle together. That's all. You think this is easy? I think this is one of the toughest things we've done all year. I do. This is probably one of the most difficult things we've done all year. You got to know, you got to understand exponents. You have a brand new thing. Oh, anyway. All right, here's a new puzzle piece. 441. Could you write that as an exponential equation? Lexi, say that. 4 to the first power equals 4. How could I write it logarithmically? That's log base what? 4 of 4 is, there you go. 4 to the first power equals 4. It's always this raised to the this equals this. How about these here? Is that correct? Let's try it. 4 raised to the 4th power. How about that? It is. 4 raised to the 4th power is 256. So how can I write that as a logarithmic equation? Log base of is, you got it. You got it. You guys are good at this. Awesome. All right, you want to get confused? No. Turn to page 175. All right. Now, these are just like the warm-up problems. Okay? And the warm-up problems you guys figured out. So let's try these. This time, they give me a logarithmic equation. The way we did this on the warm-up problem is you just turned each one of these into an exponential equation, and then you figured out the answer. So let's do that. How can I write this as an exponential equation? What? What's the base? Not n. The n is not the base. The base is the what? 8. So 8 to what power? Is it 8 to the 64th power or is it 8 to the n power? Write that down. 8 to the n power is equal to 64. Right? The base raised to the log is equal to the argument. Now you got to turn on your math brain and try to figure out what n is. So can you figure out 8 to some power is 64? Let's take a wild guess. What do you think? 2. 8 to the second power, you figured it out. N equals 2. There you go. You did it. That's it. You can do it. Let's do letter B together. What's the base? Raised to the equals 1/16. All right, there's the hard part. Now comes the easier part. Now, keep in mind, these negative exponents are what makes everybody grumpy. So remember, negative exponents just make fractions. So could I think of this as this 16? Isn't that the same as 4 squared? Right? So if I wanted to put the 4 on top, wouldn't that be n to the negative 2 equals 4 to the what? If it's got a positive exponent on the bottom, what kind of exponent will I have when I put it on top? A positive. I'm sorry. It has a positive exponent on the bottom. So it'll be negative on the top, right? Now can you figure out what n is? Yep. The answer is 4. That was a toughie. I don't even want you to do letter C. Don't do it. Do letter D. Try letter D all by yourself right now. You can do it. First, rewrite it exponentially. And then Will. Right? I don't usually have to do this in class, but I'm gonna have to ask you to stay awake. I know you can't stay. Okay? All right. It's usually like a Algebra 1 type of thing. All right, what's the base? Not E. Why isn't it E? Because what does it say? Does it say ln or does it say log? It says log. So what's the invisible number I'm pointing at? It's 10. So this is 10 to what power? -3. 10 to the -3rd is equal to n. Well, what is 10 to the -3rd? Oops, doesn't like what I typed in there. 10 raised to the -3rd. Math, enter. There it is. Did you get 1 over 1,000? Or did you get 0.001? Either way, yeah, 0.001 or 1 over 1,000 really is the same thing. It'll tell you on the answer whether you should write it as a fraction or a decimal. Yeah. Okay. Oh, hit math, enter, enter. So after you get the 0.001, just hit math, enter, enter, and it'll turn it into 1 over 1,000. So if it wants a, yeah. Let's skip E. Let's do F. What to what? Not 9n, but 9 to the n, right? So it's not 9 times n. It's 9 to the n power is equal to how much? 27. All right, now how in the world are you supposed to figure that out? Oof. Now, 9 and 27, you can't take 9 to a power and get 27. Well, you can, but it's not easy to figure out. So here's what I would suggest. Both 9 and 27 are both divisible by what? 3. So let's write this as 3 squared to the n. Would everybody agree that 9 is really 3 squared? How do you write 27 to a power? 3 to what power? 3 squared is 9. So 3 to the third is, let's try it. What is 3 to the third? 3 to the third is 27. So this is 3 to the third. If the bases are the same, then what has to be true about the exponents? They're the same. What do you do? This is a little bit of Algebra 1 review. What do you do with the exponents when you take the power of a power? Do you add them or multiply them? You multiply them. So this would be like 2n. Would you agree with me that 2n has to equal 3? Because this part right here has to equal that part right there since the bases are the same, right? If 2n is equal to 3, then what's n? 1.5 or 3 over 2. Can we check it? We can. So take 9 raised to the 1.5 power. If it says 27, then you know you got this one right. And it does. Okay. Okay. So this says write 3 logarithmic expressions. I don't want you to do that. Nope, 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 and nope. I just want you to do this. I want you to solve. We're just going to do a couple of these. I just want you to do A right now. Solve for A. Let this equal X like this. Put a little equals X after it. And then I want you to solve for X. What is that equal to? Rewrite it as an exponent and see if you can figure out what X is. I bet you can. After you rewrite it with an exponent, then you got to do a little playing around with the calculator to try to figure out what the answer is. But I'd be willing to bet you guys will get the answer right. Can anybody tell me how to write this one as a equation? 5 to the equals. All right. So what do you think? 4? Let's try. Danielle says 4. Let's give it a try. 5 to the 4th power. 5 raised to the 4th power. There it is, 625. She got it right. That's exactly right. Once you get to this point, then you just got to start trying a few numbers out till you figure out which one it is. That's good. All right, last one. I want you to do D. Put equals X after it. And see what you get. This will be our last one. I'll give you a warning. This is a toughie. I think you can all do it. It's just a toughie, that's all. Let's do the easy part together. How do I write it as an equation? 2 to the X equals, you got it. All right, now just tell me what X is. That's the easy part. Mm-hmm. 2 to some power equals -2. Take a guess. 2 to what power? -1? No. Take another guess. 2 to the first power? No, it's just going to be 2, isn't it? I need a -2. If I take it to a positive power, will it ever become negative? If I take it to a negative power, will it ever become negative? Let's try some. 2 to the -2. No. 2 to the -3. No. 2 to the -4. No. Even when I take this thing to negative powers, does it ever become negative? So what do you think? No solution. Good. That is not possible. The argument has to be positive. You can't take a positive to a power and get a negative. Even if you take it to negative powers, it just doesn't work. Okay, so here's what I'd like you to do. Here's your assignment. Turn to page 183. Page 183. I want you on a piece of paper. Don't do it in your book. Don't do it in your book, because there's not enough room. And I want you to have plenty of room to get these done. You got about 20 minutes left of class. I want you to do one problem. Number 1, I want you to do A, B, C, and D. That's it. It's just like what we were just doing, but I want you to write them on paper, okay? So do those 4. I want you to tell me what n is equal to in each one of those. And it all comes down to, like we were doing, you just kind of first put it in exponential form, and then you see if you can solve it. So you got 4 problems. Do them on paper, because I want you to have plenty of room to move things around. I don't want you to try to scribble in super tiny. Do all 4 of those problems on paper, and that's the only assignment for tomorrow. It's just problem number 1. I'm going to try to make it slow and easy today.